All right, let's get started then. Good evening, everybody. So I'm here to talk about shift left. Shift left is probably a term, I hope I'm not too loud. Is it okay? Yeah. Shift left is a term that keeps getting thrown around, right? Like it almost comes across as management jargon. A lot of people use it. Not many people actually know what is being talked about. So today, let us unpack this term. Let's rescue it from management jargon and try to figure out what this actually means for us. Also, let's dig into why it's called shift left, for instance. So I'm Anupam Krishnamurthy. I'm a manager turned engineer. Usually people go from engineering to management. I went the opposite direction. I work as a SDET or quality coach at BitGrip. It's a Berlin-based company. And until April, that is until this month, I'll be working there and then I'm moving on. Apart from coding and stuff, I'm interested in chess, running in history. Here's a link to my website. You can photograph it and scan it later. All the slides as well as the links, everything that I'm talking about, the sources will be shared to you at the end of the presentation. So I'm just putting that out there. Let's get started. So let's begin at the beginning, right? This is when I joined my team, and this picture kind of captures what we were going through. We had an end-to-end test pipeline that ran for about 3 hours, and it was a pain for maintaining, and the tests were super flaky and they were like moody, so you had to just treat them right for them to work. And so as soon as I joined the team, the rest of the team, all the developers, they were like, okay, yeah, now you're here, now this is your problem. They were glad to be rid of this problem. There was another problem. We had exposure to an external API, and whenever they changed the slightest things, our tests would break. And if they made a major upgrade, it would take us 172 hours to recover. So we actually counted this. It was a bleak situation, but we'll return to the situation and figure out how we solved this. Let's start. I'll give you an outline of how the talk is structured. What is shift left origins and evolution, how shift left helped me in my work context with specific examples, and then we do some brainstorming as to how this could be more broadly applicable at your workplace. So to begin with, can somebody help me with a definition here? What is actually shift left? Yeah, that's actually a pretty good definition. Start quality activities as early in the software development process as possible. Actually, that's a good definition, so I'm just going to go with that. It's exactly what I've written down here as well, integrating quality assurance activities earlier in the software development lifecycle.
I have a fine definition, so it's TDD but broad.
TDD but broad. Yeah, that's also a valid definition because TDD is a subset, and integrating quality assurance activities earlier. So that is where the shift comes into the place, right? Like because it's earlier, it's a comparative and it's active. All of us are actually already familiar with shift left. So let's look at how this is visualized, right? Like if you're looking at traditionally how software was developed, it was step 1, step 2, step 3, right up to step N. And once you're done with all the steps, you do quality assurance. So the question is how we go from there to having quality assurance go through all the different steps. So integrating it along the entire process. And this diagram tells you why it's called shift left. Because if you're writing this process from left to right, you're trying to shift quality assurance to the left, right? So that's the shift. And all of us are actually implicitly familiar with shift left because several practices that we perform in our day-to-day lives, several standard software development practices are actually good examples of shift left. Static code analysis, where you're getting feedback from your code before you compile it. Test-driven development, automated tests in CI/CD pipelines. An interesting example is contract testing. So let's say you have an external service that is influencing your system under test. Now, if you write tests against that service, if you're ensuring that that service is giving you the right data before you actually test your system, that is contract testing. And this is an example of shift left because you're doing this testing upstream. Let's look at the origins and evolutions of shift left. Like, where does this term come from? And a hint here is that it didn't even originate in software development. It originated somewhere else. And there's this gentleman who contributed a lot to this. Can somebody guess who this is? Whitley's giving you a cue. No wild guesses? Okay, I'll give you a cue. It says statistical quality control on the board in the background. All right, so this was William Edwards Deming, a person who's influenced all our lives, but quite unknown. Even I didn't know about Deming until not very long back, right? So to appreciate Deming's work, let me give you an example. I mean, a lot of us are quality professionals. So we have like this mindset of figuring out what could go wrong, right? But let's say you take a car and go to the Autobahn. How many of us lose sleep over whether this car is going to stop at a tunnel at the Autobahn? If we take quality and automotive quality and safety for granted, Deming is the person to thank for it. Think about it. The IC engine, I mean, any IC engine driven car, right, is driven by a series of controlled explosions. If you have a 4-stroke car going at 2000 RPM, that represents 4,000 explosions per minute. What could possibly go wrong? Deming did a lot of his work with automotive companies in Japan, specifically Toyota, and it was the revolution, the quality revolution that originated there that sent ripples all across the world, and we have him to thank for reliable automotive products, as well as a lot of manufacturing products. So let's take another story to illustrate the kind of influence, the kind of impact that Deming and his work had. Now this takes us to the late 1960s. We are at a Ford plant in the US. So there's this plant manager called Frank Pipp. What he tells his team to buy different competitor vehicles and to take them apart and put them back together. So what they are doing is reverse engineering, right? Like they're taking all these vehicles apart, they're putting them back together, getting the ideas for improving their own vehicles. So when his team was disassembling one vehicle, they got super excited. So he went to figure out what this is about. And then they told him that this vehicle here, right here, is 100% snap fit. What does that mean? So back in the 60s, if you had to put a vehicle together, you usually had to use a rubber mallet to force a few parts in, because all the parts didn't quite fit together. But there was this vehicle that they found where it was 100% snap fit, which means it fit without using the rubber mallet even once. Now Pip was suspicious. Maybe this is a fluke. Right, so he asked this team to take it apart and put it back together. And when they did, they confirmed that it was actually legit 100% snap fit. Now that car was a Toyota pickup truck. So what Frank Pipp did was he called his executive team at Ford. He called a bunch of plant managers, and all of these executives standing around this car with their suits. They're all looking at what they have just witnessed. And then there's an awkward silence. And then the plant manager clears his throat and says, the customer will never notice. And then everybody agrees with him. Yeah, that's right. And they go about the rest of their work, completely ignoring what they have seen. But did the customer not notice? Well, this is a model of the Toyota Corolla. It was launched in 1966. By 1974, Toyota Corolla was the best-selling car in the world. By 1997, it actually became the best-selling series in the world. It surpassed the Volkswagen Beetle to take this distinction. As of 2021, there are 50 million Toyota Corollas produced in the world. The Corolla story is inspiring at so many different levels. Firstly, this is a story of excellence in post-war Japan. This is a country that was reduced to, the economy was in shambles, they had little resources, and they were known for making substandard quality. From there, it went on to becoming one of the landmark cars when it came to quality. And secondly, the Corolla is not a luxury car. It's a car for the masses. It's a car of the people, and it solves their practical problem of transportation with high quality and low cost, right? And think about it, in the automotive industry where you have brands and models coming out every single year, the Corolla brand name has stood the test of 60 years. So this is what happens when you put quality at the center of your manufacturing process. And what about Ford? How did that culture go, right? Like what became of that? In 2008, Ford nearly went bankrupt when the financial crisis hit. And as of 2024, Ford has the dubious distinction of being that company in the US where the number of cars that were recalled were the highest for 3 consecutive years. So yeah, the plant manager was wrong. The customers do pay notice to these things. So let's look at, we've looked at the impact that Deming had, but what was his method? What was at the center of his quality philosophy? So let's hear from the man himself. He quoted, "Cease dependence on inspection to achieve quality. Eliminate the need for inspection by building quality into the product in the first place." It's pretty reminiscent of what we saw in that diagram, right? Where quality goes through all the different steps. Deming also said something, used to often quote something saying, "Quality is everybody's responsibility." Now, this is a cliche today, but back when he said it was actually revolutionary. So how do we get from Deming to software engineering? So let's make these subtle leaps from there. On the left-hand side, what you see is a conveyor belt where there is an assembly line, right? So on the assembly line, let's say there is a quality assurance step at the end of this, or a quality control step at the end. You're going to have a pile-up when you find defects at that point, right? And when you shift quality assurance to the left of the assembly line, you're likely to avoid these pile-ups. On the right-hand side, we have a picture of something named for a software development methodology, right? In software development, we used to use waterfall for the longest time. And waterfall is actually very analogous to an assembly line, although it doesn't quite look like that. What we're doing with waterfall is we are cascading from one step to another. And if there are defects, they are found at a downstream step and they are sent back. Waterfall doesn't quite work. It always causes problems. And we are not the first to experience this. So there was another team which made a landmark change from waterfall, and we'll look at that story next. And this team was led by a developer called Kent Beck. So now we go to another automotive company, Chrysler, where Beck was leading an IT team. This was an IT product. It was not building cars anymore. And he was working on the Chrysler Comprehensive Compensation Project, the 3C project. On this project, this project had started in 1993. 3 years, it was driven with a fixed cost waterfall model, 0 value delivered, not a single line of code that actually ran, right? So Beck and his team took over this project, and in 1996, they started rewriting the whole thing from scratch. They said, we're not going to go with this approach anymore. Instead, we are going to work with user stories, and these user stories are going to constantly change, and this is how we're going to develop. And also, we're going to write the tests before we write the code. Yeah, so this is the genesis of the test-driven development before it became popular. And they called their style of programming extreme programming. Extreme programming has made so many contributions. In addition to test-driven development, it gave us pair programming as well as continuous integrations in batches. So it was very influential. And here's another anecdote from this project. There was an anecdote where Beck met with the CIO of Chrysler, Susan Unger. And when Beck told her that we are going to work on a changing set of requirements with story cards, nothing is going to be fixed, she obviously was skeptical. She asked, how do you know you're going to be on track? That's a legitimate manager's question. So Beck held up a set of cards on his left-hand side saying, these are the user stories that we still have to work on. We'll be adding or deleting from this pile as and when the customer tells us something. On my right-hand side, I have a list of stories that we've already done. Now, we invite you to come here every month and look at how these piles change. And if you feel like you're not making progress, you can cancel the project anytime. So Ungar agreed to this system, and that's where the rest is history. So the extreme programming, I think we've had a discussion about Agile a little bit before. Extreme programming was extremely influential in the movements that came after it, Agile and DevOps. So 3 people from the 3C team were present in this room at the Snowbird launch at Aspen to come up with the Agile manifesto. There was Kent Beck himself, Ron Jeffries, and Martin Fowler. As much as I love Agile and the manifesto, there's something about this picture that always triggers me. It's the fact that there are only men in this room. I think this is a deeply entrenched problem that we have in software development, and we'll see some welcome change, at least in the quality engineering side. So we've moved from extreme programming to Agile to DevOps. DevOps, the symbol of DevOps is a continuous integration loop where you're going from planning, branching, coding, merging, releasing, deploying, and monitoring in continuous in increments in a continuous loop, where you're making these sort of changes several times a day, right? Instead of having one release in several months or several weeks, you're doing this far more frequently. But here's a question, this is a typical representation of the DevOps loop. Where does testing feature? Now, that's a trick question, because testing is integrated in DevOps into every single step of the process. So this is what DevOps formalized, and this is how we put quality assurance into action when it comes to the DevOps loop. But this presents a unique problem. Even earlier, we had looked at coordinating release tests and release changes, right? So if you're releasing once every couple of weeks or once in a month, you can always have a round of release testing before you actually make that release. But how are you going to do this release testing if you're releasing 10 times a day or even 10 times an hour? So this is where these 2 women come in, and this is Janet Gregory on your left, and Risa Crisping on your right. They too pioneered the agile testing movement. They solved this problem. They were actually testers on an extreme programming project, and they came up with a framework as to how you can use testing in this field of continuous integration. And this is, again, we are seeing here a welcome change from all the men that I mentioned in this slide. And actually, quality engineering is a great field where women have made amazing contributions. So let's quote from, they wrote this book, Agile Testing, in 2009, which is a seminal book in the field even today. And in the book, there's one quotation: with Agile, it's not only the testers or a quality assurance team who feels responsible for quality. This is the job of the whole team, not just testers or designated quality assurance professionals. Everyone on an Agile team gets test infected. Once again, reminiscent, right? It's echoing the same message again and again. Now, all of this is fine. We've looked at the historical timeline. I've told you a bunch of stories. If you try to say these stories to a manager and try to change processes, they're going to ask you, so what? What are the results? Why does all this matter? So this is where we go into a study from the IBM System Science Institute. They looked at the cost of fixing a defect in terms of time or money. The later a defect was discovered in the process, the more time it took. And we're looking at a difference in order of magnitude of between 1 to 100. So that's 2 orders of magnitude from design to maintenance. There are further studies that looked at the efficacy of TDD. And it was found repeatedly that using TDD helps you avoid at least 50% of the defects. And these 2 numbers are cumulative. Firstly, you're avoiding 50% of the defects. And the defects that do remain because of shift left are much, much cheaper, and they're much more efficient to solve. So I think this is the value proposition of shift left, and this is why it matters. So I'm going to invoke Benjamin Franklin to give you a TLDR for this historical overview section. And we move on to the next section, where we look at practical examples of how shift left helped me in my role. So we returned to that dumpster fire that we left off from earlier. I was a new quality engineer in this team that did not have a dedicated quality engineer. And we had this pipeline which is super fragile, which was running for 3 hours. And nobody was excited to do this work. So firstly, the pipeline ran for about 3 hours. And then it would take 1 to 3 hours for people to analyze and fix the defects that happened in the pipeline, right? So it was nobody's favorite job. And what we also noticed was that this analysis was done only by 2 experienced developers in the team. So we changed the process. The first thing we did was we said, everybody on the team is going to take turns to perform this analysis and debug these tests. So we went from having specialists do this to actually pairing on this task and doing it in turns. In 1 week, there will be 2 people designated to doing this work. And I quickly got a grasp of these tests because I understood how they were working or how they are fragile. So I trained a lot of the developers to do this analysis themselves. Most importantly, we measured the amount of time it took for us to perform this analysis, and we saw how that changed. So this is a graph that's titled in German, and it says the amount of time it takes for fixing tests. And we started from 2 to 3 hours a day on the left-hand side of the graph, and we went down to less than half an hour a day. Most importantly, when developers started seeing the problems in the tests, it fundamentally changed the way they worked. Let me give you an example. We noticed that we had way too many end-to-end tests in our code base and too few integration and unit tests. So with new tickets, they started writing integration and unit tests and started replacing some of these end-to-end tests. Gradually, we started improving the pipeline. And in a period of 6 months, we went from a runtime of 3 hours to 10 minutes. So this is where the value add of shift left truly lies. When developers get involved in quality engineering, they get they realize that this is not somebody else's problem. This is their own problem. And rather than handing this problem to somebody else, they're going to be fixing it and preventing problems from occurring in the first place, right? Like that's the fundamental shift. For the second story that I have with shift left, it reminds me of this movie called 127 Hours. And the reason I say that is because of this number 172. If I were to make a movie about this story, I would call it 172 Hours, because that's how long it took for us to recover from a problem. And what problem was this? Like I mentioned, we had exposure to an external API. And when they made a major change to their API, it would take us 172 hours to recover. And again, we tracked this using timesheets. And that, just to put that in perspective, that is 22 days. That's a whole developer month worth of effort for doing work that adds little value to the customer, right? And the whole process was so painful that it makes you want to rip an arm off. Now you see the connection between the previous slide, perhaps. So let's look at the setup, right? Like what is causing this problem? So we had our development system here, and we had front-end tests against this development system. We were mostly a front-end focused team. So we are like, we have these front-end tests. If these tests are reliable, we release. But then we had a dependency on this external API. And whenever that API changed, it would break our front-end tests. So how do we start tackling this problem? The first thing we did was we added a layer of contract tests. We first made sure that this external API is delivering that data and the kind of behavior that we need to validate our front-end tests. So we caught these issues upstream. This made the analysis of our front-end tests a lot easier. It saved us a lot of time. More importantly, we could share these contract tests with our external partners, and they could run these tests before making releases, right? So proactively, we were avoiding some of these problems from ever occurring. Nevertheless, we still have a tight coupling to the external API. You'll notice that even though we have contract tests, when something changes there, something will break here. So how do we go even further? That is by adding a mock server. So we added an API mock server to simulate some of the responses of this external API. And this mock server especially had those endpoints which were fragile and which were likely to change and break our tests most of the times. right? Now, with this change, our pipeline became 10 times more stable, and we actually had enough confidence to move to continuous delivery. And as for the amount of time it took for us to recover, over a period of 1.5 years, we came down from 172 hours to 4 hours. So that's from going from 1 month of effort to 1 afternoon or 1 morning of effort. See, one of the facets of shift left is that it fosters collaboration. I think that's something that we also saw in the previous presentation. This is a picture of a barn raising event. And barn raising is something that the Amish farmers do. Now, Amish are a community of farmers in Pennsylvania in the US, and they are known to help their neighbors out to in raising barns, right? Like, so there's a picture of that. And what shift left did, at least in my case, was when it came to fixing a lot of the end-to-end tests which are front-end focused, I had to team up with front-end developers. I learned a bunch of front-end development from that, and then we had to replace a front-end framework. So again, I collaborated with front-end developers. When it came to building the mock server, I had to collaborate with back-end back-end developers to find a suitable solution. So I learned a bunch of front-end and back-end development. They had this testing and quality mindset from me. So all of this knowledge got diffused and we became better professionals overall, right? Like, this is another side effect of shift left, not just with quality assurance, right? Like, we're all becoming better professionals. So how did this actually transform our role? We went from testing tickets and releases to more strategic work. We improved our end-to-end test efficiency from 3 hours to 10 minutes. We installed 2 new test frameworks, one on the front end, one on the back end. We set up contract testing and a mock server, and we migrated our CI pipelines from an outdated Jenkins to a more modern GitLab. So as you see, we went from more operative work to strategically relevant work. But here's the slide that's probably very interesting. Crucially, this kind of work gives you the leverage to negotiate a raise or a promotion. When you go to your manager and you tell them that I've saved you 1 month worth of developer efforts, it gives you a far more legitimate ground to be paid more. Now, if the problem with operative work is it doesn't give you that sort of an argument, right? Like, if you go to your manager and if you tell him I tested all these tickets and I tested these releases, you should give me a raise, the manager is likely to say, hey, thank you for doing that, but that's why you're already paid. But if you give them these results, right, it's hard for them to argue. So this is Ben Franklin's second appearance on this presentation, and now you know the source for the first picture. A lot of people like this appearance better. So once again, for summarizing this section, I'd like to invoke a legend. This is Gene Kim, the author of the DevOps Handbook, as well as the Unicorn and Phoenix project. And what he said was, improvement of daily work is even more important than doing daily work. And no worries, I'm throwing a bunch of references at you, but all of this is documented in a GitLab repository. I mean, it's all available to you at the end of this presentation. How can shift left help you? Now, let's turn the lens around and let's do some brainstorming as to how this can be more broadly applied. Now, I've spoken about a few transformations that we've carried out, and those results are substantial. But don't get intimidated because they happened over a long period of time. That doesn't mean that shift left cannot start small. You can start small right from tomorrow at your workplace and change a few things, right? Like, so let's just do some brainstorming on how that can look like. Quality engineers are active participants in refinements and system design meetings. So even before development starts, you start with quality. You go when your ticket is being refined, you can already look at, okay, yeah, if we implement it this way, it's going to cause X, Y, and Z problems. So maybe we should be looking at a different kind of implementation. You can do some, requirements testing, figure out how, the acceptance tests that are written down, document that in the ticket. You can catch edge cases so that developers implement these edge cases even before you have to find them later, right? You can perform nightly test failure analysis along with the rest of the team in rotations. You can also do pair programming, or rather pair testing, with developers and teach them how to perform explorative testing so that they are better able to catch edge cases of their own tickets. If you're looking for more ambitious ideas, you could help your team move to continuous delivery if you're not already doing that. Let's say beforehand, if you were releasing features once in every 3 weeks, and if features are developed and approved later in the QA check column, release candidates are deployed on the release branch, you call for a feature freeze, and then the release candidate is deployed. You can go from there to having fully automated releases and automated quality gates that you actually have a high degree of trust so that you can create deployable artifacts several times a day or several times an hour. Most importantly, the QA team is no longer a bottleneck for releases, right? You have you are able to work at the meta level, improving these processes. Another TLDR, another legend, every situation can be substantially improved, even the sky is not the limit. That is Eliyahu Goldratt, the author of the book Goal, which is all about process improvement and operations. So we come to the last slide of this presentation where I'm going to tell you yet another story. And this story is another story about Edwards Deming. If we go back to the 1950s, we are looking at a post-World War II American economy. There was a manufacturing boom in the US, and Deming spoke with a bunch of manufacturers and told them that you need to put quality ahead of profits. Just picture this, right? Let's say you take a bunch of American executives in their suits, and if you tell them to put quality ahead of profits, what are they going to do? They're going to laugh you out of the room. That's precisely what they did to Deming, and that's why he took his work to Japan, where it was better received. And, all that in Japan happened. So fast forward to the 1980s, the American market is having a lot of competition for Japanese goods, and American productivity is slowing down, Japanese productivity is increasing. So that's where Deming makes a comeback. NBC News commissioned this documentary called If Japan Can, Why Can't We? That's where Deming makes a comeback. And the point is, if you do good work, if you do excellent work, nobody can ignore you. I'm going to say something provocative here. In the world of software development, QA is treated as second-class citizen. When budget needs to be cut, QA is the first one to go. And we've spoken about shift left, we've spoken about economic benefits, we've spoken about quality benefits, we've spoken about efficiency. There's another perspective that is missing here. That is the moral perspective. Traditional QA is set up for failure. Let's say there are 3 outcomes when it comes to traditional QA. You test a ticket and you don't find any defects, and the feature works properly, the developers get the credit. You test a feature, you find problems with the feature, and you flag it. You are called a bottleneck for holding back releases. And somehow, despite your testing, you're not able to find some defects and they end up in production. You're blamed for not having caught them earlier. The way it is set up is either you lose something or you don't gain anything. And that is simply not fair. That is simply not morally correct. Developers have to take responsibility for the quality of their own code. And now that we have tools and processes to actually enable this, we have excellent tooling, all the methods, it is no longer conscionable. It's no longer acceptable to do things the wrong and inefficient way. So this is my message. Shift left lies at the heart of this change, right? It can actually enable you to transform your role from being stuck in the operative mud of firefighting to having a strategic role where you're making systemic changes to quality assurance. So this is my appeal to you as I end this presentation. Shift left, move forward, and make this transformation. Thank you. Thank you for paying a lot of attention. I'll open up for questions just after a couple of slides. Special thanks to my employer BitGrip for actually, all the work that I presented is work that I did with them. And we are now hiring for a systems quality engineer. I'm leaving the team, and I've already implicitly onboarded you into this job. So that was my motive all along, just kidding. So anyway, you can use this QR code to access that job opportunity. And a huge thanks to Whitley. I mean, a lot of the presentation, a lot of the ideas that you see here were actually stuff that we brainstormed together. So they're not my ideas alone.
Oh, come on.
I mean, I've stolen.
No.
So, and he really helps you prepare, right? And if you have any sort of inclination towards presenting here, make sure to reach out to him. He's a great guy. And also thanks to Qase and to this meetup to provide me this opportunity. It was really lovely. And I'll just leave this last slide here. On the left-hand side, you have the sources. I mean, all the slides that we've seen here, as well as the recommendations I made during my presentation. And my LinkedIn profile is on the right if you ever want to connect or reach out.
Very good books and the sources there. Do take a photo.
Yeah, and now we can actually open up for some questions, or we can even discuss it over pizza, please.
Yeah, we have pizza now, so I suggest we talk to Anupam and everyone else here, with having pizza. So it's 10 past